Okay, task 2 is about this data set. And on GitHub, there is a link to the Google document which have the data that you need. By the way, you can download it by using the file and then download it as a XLSX, meaning Excel file, and then you can open it on Excel. And the data should look like this. Okay, what this data is all about. This is the data from the Freedom House and also the data from the United Nations Human Development Index. The Human Development Index is easy to understand. It's talking about the living standard of the citizen in each of these Asian countries. Higher meaning better. Okay, and then the column D, which is the electoral democracy, which is not defined by me, it's defined by the Freedom House. If that particular country with 1, meaning that that country has the electoral democracy. And then there is 2 more columns. One is the political right index. Also, it is from Freedom House, not me. So lower meaning higher level of political right. Okay, it is the same as the civil liberty index. Lower meaning higher level of civil liberty. Okay. So I recap it once again. HDI, Human Development Index. Higher meaning higher level of living standard. Civil liberty and political right. Lower meaning higher level of political right and civil liberty. Okay. And electoral democracy. 0 meaning low democracy, no electoral democracy, and 1 meaning has the system of electoral democracy. Okay, so if you want to know more, you can go to Freedom House and then the website of Freedom House, and they include the methodology how they rate those countries with different level of civil liberty and political rights. Okay. And once again, I must stress that that is the opinion from the Freedom House, not me. Okay. So you may have different political opinion about those score and also the system as well. So. But this is not a debate on the political system. This is a statistical class. So let's focus on the data analysis. Okay, the first analysis is to complete this table. This table is to stratify your data into country with electoral democracy and country with no electoral democracy, and then calculate the mean political right index in this box, and also the standard deviation, and etc. etc. Okay, and that one is easy because you can do it with pivot table. Okay, zoom in a little bit. Okay, the first step is to select all the data, and then go to data, insert a menu pivot table, Okay, and then drag the electoral democracy into row. And suppose we need to calculate the political right index first and change it to average. And then drag it again, the political right, and then change it to STD DEV, low P, okay? This time, no P. And now you get the average and the standard deviation of the political right index for all the country without electoral democracy, and this one with electoral democracy. And as you can see, country with electoral democracy have a lower score on the political right, meaning higher level. And then you can do it also with the civil liberty and also the HDI. And now you get all the numbers. As you can see, country with electoral democracy have lower score on political rights, also lower score on civil liberty, and also the more or less the same level of human development index. And then you can fill out, using the number, you can fill out this table. Okay. Straightforward, right? Any questions so far? Everyone can get those answers, right? Okay, the first thing, remember, the standard deviation we use this time is STD DEV, not STD DEVP, because we are doing a sample, not all the country in this world, so we use the sample standard deviation for this calculation. And okay, I want to make sure that you have no questions before I move on, because okay, it means no questions, then I move on. The second part is to construct a political right the scatter plot between the political right index and HDI. And because the political right index is an ordinal variable, and HDI is kind of like a ratio in terms of the scale of measurement. So in order to show the relationship between these two continuous variables, we will use the scatter plot. Okay, and the method to generate that scatter plot is like this. Okay, charts. highlight all of highlight the data like BA to E, and then scatter. It will show you all the thing, but that is not what we want. So, any better method? Okay, let's try this way. Highlight that way. Okay, this is the lazy method. I just copy the political right just on the F column, highlight only the numbers, and then insert a scatter plot, and then you get something like this. That is the answer actually. This is the quick method. This is actually a scatter plot, and if you like, you can add a trend line. Click any of the data. Okay. Right click any of the data. Right click or click. Yeah. And then right click it and then add a trend line. You can add a trend like this. It seems that country with a higher level of political right index have a lower level of HDI. And you can see from this line that, for example, the country with the highest level of HDI, it have a relatively lower average level of the political right index. I must stress that it seems to be a trend. Okay, it seems to be a trend because you add the trend line and then there is a downwarding trend, but we don't know whether it is really a trend. Okay, so and the next part of the question is to calculate the correlation coefficient. Okay, if you remember in the class by Dr. Leung, there is a coefficient called correlation coefficient. It ranges from -1 to 1, right? And higher that number, or more positive or more negative of that number, meaning the relationship between these between two variables is very strong. Okay, but you need to do that calculation, which can be done by using the formula interface equal CORREL, and then that function have two arguments, and then you just, the first argument, you just select your first variable, meaning the human development index. And the second argument is the PRI, political right index. then you can close that paren, and then you will get the answer, which is negative 0.1 something, 0.16 something. And negative meaning the relationship is inverse, meaning higher of x, y will decrease. And then the magnitude of that number determine how the strength of the relationship. And you can go back to the slides from Dr. Leung and see whether 0.186 is strong or not strong, things like that. But I can tell you it's not strong. Yeah, and yeah, that is pretty much it of task 2. And then the final part is to ask you to write a short story about your findings from this table, and also the scatter plot and the correlation coefficient. That is your job, not my job. I'm not good at writing that kind of story, so try your best. Write a story that your grandma will understand. Okay. And from this question, I can ask you a theoretical question. Okay. We find that there seems to be a very weak trend between the Human Development Index and the political right, right? This is a scientific term. Is there is an association, very weak association, between the HDI and the PRI, political right. Can we say that the Human Development Index cause the increase or decrease in the political right? Okay, you can refer to the slides from Dr. Leung and then try to answer these questions about the correlation and causation things. And we will come back to the correlation and causation next week. Okay. And there are some set of criteria to determine whether a correlation is a causation. Okay, there should be 4 criteria. And read the slides and then come back next week. We will have a more deep discussion on the problem of causation. And this is all you need to do for task 2. Any problem on task 2? Okay, cool. And then we will move back to task 1. Okay, task 1 is about the independence of 2 events. Okay. Okay, in order to show that A and B are independent of each other, the method is to determine whether the probability of A is equal to the probability of A given B. Okay, this is another definition. But in most of the time, we use this one. And we can do it by using a contingency table from a contingency table like this. Okay, for example, this is a result from the survey from the Hong Kong U. which is like a few months ago when, okay, for those who follow the Hong Kong politics, there is a chief executive election proposal proposed by the government. And then in June, the Legislative Council need to approve that proposal. And because of the umbrella revolution or movement last year, that election proposal get a lot of attention. And 3 universities in Hong Kong conduct a series of rolling survey on the approval or the supportive of that government proposal for like 2 months, and they conduct a lot of survey. And this is the results from the last survey. And if you want to know more, you can go to this website. This is all the results from that survey. You can see that there is some people support it. Actually, more people support the government proposal than those oppose the proposal. And this is the overall less support, meaning the support minus the oppose. And in each survey, they also did a deep analysis, high-level analysis on the background. Information of the respondents and what is their answer for the approval or oppose the government proposal. And they created a table like this. I actually extract the numbers from this table. So table should look like this. There are 3 groups, 3 age group in their survey. And then for each age group, there are some people support the proposal and some against their proposal. And the first step for us to do the analysis is to enter those data into Excel. So 63, 316, 145, 115, 243, and then 64. And you can also type in the age group, 29. Support against. And actually, you can calculate the probability of support, which is equal to the sum of all the supports divided by the sum of all the numbers. And then you can also calculate the probability of support given the age equal to 18 to 29. Which is equal to support 63 divided by the sum of all the people from the 80 to 28. And also you can do it for all the other age group. Okay, from the data, you can see that, okay, the probability of support is 55%. But when we do the conditional probability, conditioned by the age group, you can see that those in the younger age group, the probability is lower. And in the older age group, the probability is higher. And from the analysis, it seems that the probability of support is not equal to the probability of support given age. So we can say that it seems that the two events are not independent. They depend on each other, meaning that the age group is related to whether or not that respondents support or against the government proposal. Okay. Remember, independence meaning no relationship. Okay. But this is not the method that we use. Okay. The reason why this method is not working is because we can only do this kind of calculation if we are doing the population survey. Okay. For example, if we have the data on the entire population of Hong Kong, and then we can do the calculation like this. But the survey conducted by Hong Kong U is just a random sample of the Hong Kong population. It is not the entire population data. So we need to use this small sample to make prediction on the population. Okay, and the method that we use is called chi-square test, which is quite difficult to master and also somehow difficult to study as well. But we will try. This is the road. Okay. The first step is we need to calculate the column sum and the row sum. This is our first step when we need to calculate do the chi-square test. Okay. And we can do it like this. And also the row sum. And in this shell, we need the total population, total number of samples, so which is equal to the sum of these two numbers. Okay. The first step should be straightforward. And then we copy all this number paste it, but using the paste special, and we just want to paste the values, not all. Okay, I repeat it once again. Copy, and then paste special, just the values. And for example, 178 in the top part is a formula, but in the lower part is not a formula, it's actually a values. Okay. And then we delete all this number. Just keep the column sum and the row sum and the total number. What we need to do, this number is what we call the observed count, and what we need to calculate is those what we call the expected count. And the method to calculate the expected count is like this. Paren the column sum times the row sum divided by the total number. And you can do this for all the rest of the shells. One times this one divided by that one. If your calculation is correct, those numbers should look like this. Okay, what that expected count mean? Okay, this expected counts actually is when the count is the count when the probability of support is equal to the probability of support given the age group is the same. It's the same. Then this is the expected count. And okay, now we have the observed counts and also the expected count, and then we can do the chi-square test. The function is called the CHI-SQ, dot test. The first argument is the actual range, meaning the observed count, but we only need these 6 number, excluding the column sum and the row sum. And the second argument is the expected range, meaning the expected count. Again, these 6 number. And then do the calculation. You'll get something like this. That number is the p-values from the chi-square test. But okay, there is a e minus something, meaning the number is very small. Okay, 0.00000 something, and then 1. It's just meaning extremely small. Okay. Okay, how to interpret these p-values? The smaller of that p-values, meaning we have more evidence from the sample data that the 2 events are independent. More smaller p-values, meaning that more evidence, high level of evidence from the sample data that the 2 events are independent. Okay. Now, these p-values is extremely small, meaning very significant. The evidence is very strong, and but we don't know how significant is significant. Okay, the question actually gives you the level of significance, which is 5%. So, if the p-values from the chi-square test is less than 5%, we can say that the 2 events are independent. Okay. If the p-values is less than the significance level, meaning 5%, and then the 2 events are independent, okay, so in this crazy laborious exercise, we know that the 2 events are independent. Okay. So next time, when some people conduct a survey, a random sample survey, and then they say that A and B are related, you should ask for the p-values. And then based on that p-values, you can make that judgment whether or not the 2 events are really related. Okay. No. Sorry. Are not independent. Okay. Okay, I repeat it once again. You should know how to do the expected counts, right? It's just the column sum times the row sum divided by the total number. And then use the chi-square test function to calculate the p-values. And then we need to interpret that p-values. If the p-values smaller than the significance level, in most of the time it is set at 5%, we can say that two events are not independent, meaning they are related to each other. Okay? It's just like a mechanical interpretation.
So the observed count is the count if they were independent, they would be the number set.
Oh, I mean the observed count is the results from the survey.
I'm sorry, the
Expected count.
Yeah.
Expected count is the count when the two events are independent.
If they were, then this would be the number set you should see in the expected count.
Yeah. And if the two events are independent, meaning they are not related to each other, you're seeing that the observed count should be very close to the expected count. Yeah. But in this case, you can see that, okay, for example, for this age group, the expected count is way different from the observed count.
Wait, so our p-value is less than the significance?
Less than.
Yeah, so it's none.
Yeah. So actually meaning the two events are related.
I don't understand why the expected count is calculated that way. Why it's row.
Okay. It can be calculated in another way, but the results will be the same. But it is conceptually more, should be conceptually better. Okay, the method is like this. We first calculate the probability of support from the data, which is equal to that one over this one, right? Now, that one times this one we can also calculate the probability of loss support, which is meaning 1 minus that one. And then that one times this one. Oops. You get the same number. And then you do the calculation for orders times support. And total number of people from this group, and then times the not support. You get the idea. First, you calculate the overall probability of support, and then based on that probability, we multiplied it by the total number from each age group, and you will get the same expected count. That expected count is meaning that when the probability of support is the same across all three age groups. So okay, cool. actually, after you know the concept of p-values, you can also calculate the p-values for a correlation coefficient. Okay. Is it available from Excel? I'm not sure. Okay, then just leave it. It seems that Excel didn't have it. So you can also calculate the p-values for a correlation coefficient. If that p-values is so small, you can also say that that relationship is significant. But anyway, Excel didn't have it, so just leave it. And if you have no questions, you can go now. I hope that this week assignment is not that heavy, so you can have more time to do other homeworks.